Through the magic of photography, the eclipsing sun races across the sky. And a ship passing through the Panama Canal makes the half-hour trip in seconds. Watching a plant a building by time-compressing stop motion is not only amusing, but in great contrast to the days, even years, of pre-planning and pre-engineering required to bring such a plant into reality. Officials of Reading Anthracite carefully study all aspects of the problem related to producing a constant grade of quality coal. Conferences are held with engineering company men to jointly study all aspects relating the economies to the market needs. The plan is submitted and approved. Engineering firm officials and engineers spend many hours establishing the proper course. At last, the plant is envisioned. It will combine a washing plant with cyclones and flotation for the extremely fine sizes. Larger sizes will go to a multi-stage heavy media separation plant using 2-gravity HMS drums. Single-gravity HMS cones will treat intermediate sizes. The critical path system is indicated as one method to control the tight scheduling of engineering, equipment selection, construction, and startup. The target date is set. Constant checking is required to maintain the schedule. Early engineering drawings are related to a miniature model. The plant will have 4 heavy media separation cones and 3 large 2-gravity heavy media separation drums. All will be combined in this most advanced of heavy media separation coal washers. Now the detail engineering begins. Calculations are checked and rechecked. Equipment catalogs are studied to select the best possible combinations of elements in the new St. Nicholas breaker. Engineering instructions for the field men are dictated, typed, and sent on their way. Orders are placed for equipment with tight controls on timing to meet scheduled completion dates. Previous engineering is updated for the new combination mobile mill. More instructions are prepared from engineering notes. Hundreds of blueprints are prepared for equipment suppliers and for field use. Covering letters must accompany drawings. Field men coordinate engineering with construction, which is now well underway. All 3 drums have been positioned. Their feed snouts look like elephants at bay. Crane operators carefully raise the steel into place, where it is guided into position, tied down to make way for another section. Every piece of steel has its assigned location noted on drawings for proper placement in the structure. All are positioned, ready for use. A prefabricated stair section is raised. down. And is tied in place. All this while, mining operations continue. Tens of thousands of yards of waste overburden must be removed to get at a vein of high-grade anthracite. Drill rigs prepare for blasting, while fleets of trucks remove the overburden. Hungry shovels keep the steady stream of trucks filled and on their way. More blasting rips out another section of earth. Huge buckets can haul out 25 yards at one bite. The shovels literally walk to work. After taking up new positions, they are ready to bite out more tons. The struggle to reach veins of coal takes men, machines, money, and time. Then, too, it changes the contour of the land. Later, the land will be restored to its original beauty and service to the community. Run of mine from the freshly opened pits is stockpiled for the now completed new St. Nicholas breaker. Load after load begins its route through the new breaker. Feed to the fines plant is fed to shakers, crushed, screened, and washed. And sized on hydrotators, which are carefully controlled at a central station. Space is already engineered into the new plant for cyclones to produce a sized coal is stockpiled as it drops from the fines plant chutes. Beyond these piles is the conveyor galley leading to the heavy media separation section of the new St. Nicholas breaker. Oversize from the fines plant is brought to the HMS section. The feed is split to a twin shaker system which sizes the incoming raw material. The segregated sizes are routed to either the proper heavy media cone or drum separator. The incoming fines plant feed to HMS contains waste in the form of wood and rock, which must be eliminated. Each drum has a low-gravity compartment and a high-gravity compartment. Wood, rock, and coal first enter the low-gravity liquid, where the wood floats off, but the heavier rock and coal sink. These heavier particles are picked up on lifter bars, and dropped into a launder, feeding the high-gravity second compartment. Here, the rock sinks, is lifted up, and is drawn off as waste. But the coal floats off as a final low-ash product. At the Reading Coal Quality Control Laboratory, 3 graduates contain water, low-gravity liquid, and a high-gravity liquid. In water, the coin sinks, but dry wood floats. Waterlogged wood sinks in water, but floats in the low-gravity liquid. Both rock and coal sink in the low-gravity liquid. In the high-gravity liquid, the rock sinks, but the coal floats. This transparent model has a low and a high-gravity section. To demonstrate, feed is represented by green for wood, orange for rock, black and red for coal. In the first compartment, low gravity, the wood floats, but the rock and coal both sink and are lifted as the drum rotates. They then move to the second compartment, high gravity, where the coal floats, while the rotating drum now brings the sinking rock up and out on the launder to waste. The final coal product floats off. In the new HMS plant, the same thing takes place. Wood waste floats off in the low-gravity compartment and joins the sink rock product from the opposite end section and combines as a total waste product. At the high-gravity end of the drum, the media bath is washed free, leaving constant quality coal. The HMS cones recover smaller sizes in the same way. One pass around the top floats the finer coal off, where it moves to washing screens to remove the heavy media liquid bath. The result is a constant grade of high-quality coal in each given size. The heavier rock particles sink in the cone and are carried away as waste. The secret of constant quality control in all sizes is the overall control engineered into this finest of coal preparation plants. All operations are controlled from this point, and both gravity and operating information is recorded. During startup operations, WEMCO engineers drew off media samples from drums and cones. These were weighed on density scales and checked against automatic equipment gauges, which indicate liquid gravity in a given section. The heavy media, washed off the coal, is recovered on magnetic separators, which discard all but the magnetite used to create the heavy media bath in drums and cones. If gravity of the returning media is too low, new magnetite is added and is automatically fed into the separating drums or cones at predetermined correct density. The end result is quality controlled coal in each market size. Each size accumulates in its own coal pocket for loadout in rail cars or trucks. If special low ash coal is desired, all sizes can be reprocessed in a fourth heavy media separation cone having a medium liquid density. The standard quality coal from drums or cones flows to storage pockets, is given the Redco identification, and is ready for loadout. A steady stream of cars enters the loadout section. Coal chutes, designed to minimize breakage, drop coal into cars or trucks to make local deliveries. From the new St. Nicholas breaker, Reading Anthracite brings to Pottsville, to Pennsylvania, and to the nation the latest improvements in quality-controlled coal cleaning. Reading Anthracite.